Hi everybody, this video is going to walk us through how to calculate percent or use percent to calculate different amounts and how to calculate interest. So the first thing we need to remember is that percent literally means percent or per 100th. So what we talked about in the previous class about interchanging between a percentage and a fraction and a decimal is going to be really helpful for us here. This first activity helps us compare a fraction, decimal, and percent in all the equivalent forms. For example, 63%, since it's per 100, we can rewrite that as 63 hundredths. And using our understanding of the place value structure, we can write it as 0.63, which also means 63 hundredths. 9% would be 9 100ths, and that would be equivalent to 0.09, or again, 9 100ths. Similar to the work we've already done with fractions and decimals using a 100 grid, we can use that to help find the percentage of shaded and unshaded regions, while also showing the equivalence between the fraction, decimal, and percentage representation. So in this one, we know the denominator is going to be 100 because it is a 10 by 10 grid. And in this case, we're looking for the shaded. So we're looking for the number of shaded regions, little squares. So we have 10, 20, 30, 40, 50, 60, 7. From the work we did a couple classes ago, we know that this would be equivalent to 0.67 hundredths. And from either of these notations, we can then write that 67% of the entire figure is shaded. Unshaded, we still know the denominator is going to be 100, but now we're counting the ones that are not shaded, so 10, 20, 30, 3. If you notice, the sum of the the ratio of shaded to total and unshaded to total will equal 1 whole. Same thing with the decimal representation. This will equal 1 whole. And the two percentages summed would be 100%. If we look at the second example, we have now only 4 shaded blocks out of 100, which tells us our decimal is still going to be 4 100ths. We don't have a digit higher than 0 in the tenths position because we don't have a full column or row shaded. So this means this is 4%. I really like using the visuals with this because you can see why it would be 4% compared to something like 40%. So having the juxtaposition of those two can show students why it would be 4% and not 40. Using what we just talked about here about finding the sums between these, we don't need to count the number of unshaded regions. We know that the number of unshaded regions or squares is going to be 100 minus the shaded. So that would be 96. So our decimal equivalent representation would be 0.96 hundredths, and our percentage is 96%. So by comparing the percentages, we can see the number of unshaded greatly outnumbers the percentage of shaded. So I really like this activity because it connects to a previous structure to help students see the equivalence. And then you can see in the next part, it removes that visual. They still give an example of a completed problem, and then they're asking students to now fill in the blanks. So we're switching the order. We're now giving the percent, So we know the denominator in any percentage is always going to be 100 because it's percent per 100. And the numerator is the value. So it would be 17 hundredths. And then the decimal equivalent, because it's 17 hundredths, would be 0.17 17 hundredths. And then you can see how we went from still very not pictorial, but concrete, to now having an application. So we're told the ratio, typically 7 out of every 100 babies born in River Creek Hospital have a birth defect. Most of them are minor. So we're given a ratio, meaning usually a fraction representation, and we want to know the percentage. And they were kind here, and they gave us the relationship out of 100. So we can use the similar structure that we just did in the first two problems. So we're told it's 7 out of every 100. If you wanted to, you could find the decimal equivalents, so 0.07. But we didn't need that to answer this question. It's just asking us the percentage. After we've answered part A, we can now answer part B, and this one is asking for how many do not have a birth defect, which is similar to what we did with the shaded and unshaded regions. So we know the total would be 100% of the babies, 7% have birth defects, so that means it would be 100 minus 7. So 93 out of 100 babies would not have a birth defect, so 93%. This next question is an application of the percentages. So how many babies with birth defects would you expect to find out of 500 babies? So we know it's every 100, so we could just add 7 5 times. But if we wanted to use the percentage here, we know 7%, and we have the decimal approximation here, or decimal equivalent. I'm sorry, it's not an approximation. So we can take that and multiply by the amount of babies. So in that case, it would be 35 babies. There are many other ways you could approach that problem too. This next page is changing the visual. We're not using 100 grids anymore. We're using other visual representations. So we're given, in this case, pencils, and we're asking what part of the pencils are short, meaning what number of the given pencils are short. So in this case, we can see there are 2 short pencils out of a total of 5. So 2 out of 5, or 2/5. And now our denominator is not 100, but at this point we have worked a lot with finding equivalent and common denominators. So we know a percentage we would need to write with a denominator of 100, and we know they need to be a multiplicative relationship. So 5 times 20 is 100. So 2 times 40 gives us the numerator there. Then, because of all the work we just did, we can find the percentage representation. So you can see this next example is keeping with the same type of problem, but now we're changing the amounts of pencils. So we're still looking for the number that are short, the amount that are short out of the total. So in this case, we have 1 of the 2 pencils are short. We can see the multiplicative relationship to get to 100 is by 50. And remember, it always has to be a denominator of 100 with a percentage. So our numerator would be 50, meaning we would expect 50 pencils out of 100 to be short in this scenario. So our percentage is 50%. In this problem, the total is 4 pencils. That's why our denominator will be 4. and we have one of them that is short. We know the denominator has to be 100 in order to be able to write it as a percentage. So we're looking for a multiplicative relationship here. 4 times 25 will give us 100. So our numerator is 25, meaning 25%. Now we're taking away the visual. We're given a starting fraction, and we're asked to calculate the fraction equivalent with 100th. 100 is the denominator, and then find the percentage. So we're still using multiplicative relationships. 10 times 10 will give us 100. So we have to multiply by a special form of 1. So 4 times 10 will give us 40, meaning 40%. In this one, our denominator is 20. So we have to look at a multiplicative relationship here. And we see 20 times 5 would give us 100. So 11 times 5 will be needed for the numerator, meaning 55 or 55%. These next two problems are asking us, now we're still not using a 100 grid, but they're saying this whole rectangle represents 100%. And now we're subdividing it into different amounts of bars, equally spaced bars, equally sized partitions. So one way someone could approach this is to count the number of increments and divide it into 100%. So in this case, we have 5 increments. So that means each increment should represent 20%. If you didn't want to approach it that way, you can start with just the fraction. So the fraction in this case, we have 3 shaded out of 5 total regions. And then you can use what you did up here and convert it to hundredths and then to a percentage. If we went through and labeled in this way, we can just find the sum of the shaded regions. So 20% plus 20% plus 20% would be 60%. In this case, we have 2 parts of 5 total unshaded, and we knew that needed to happen because these needed to add to 1. And then the unshaded would be 20% plus 20%, so 40%. This next one has repartitioned the whole. So we can see we have 4 total parts. For shaded, there are 3 total parts, meaning 100 divided by 4. Each of these is going to be worth 25%. This could be an example of a tape diagram. So our shaded region would be 75%. Oops, there was already a percent sign there, sorry. And our unshaded is 1 for 25%. In all of the problems on this page, the denominators of the given fractions were factors of 100. It won't always happen that way. Sometimes we also have percentages that are larger than 100%, meaning greater than a whole, and that's okay too. It just means in a base 10 model, we would have one whole shaded and then parts of another one. So in this example, we have one whole, which would be 100, and then we have 10, 12 of another. So in total, we have 112 shaded squares, which means the decimal would be one whole in 12 100ths. So the percentage is 112%. In this next one, we have one whole, meaning 100 shaded blocks, and then we have 9 in the other one. meaning we have 109 shaded out of 100 for one whole unit. So our decimal would be 1 whole and 9 100ths. So our percentage is 109%. I'm going to skip number 8 and 9 because it's very repetitive of the other things we've done. I thought we would look at the tree problem. So two trees are growing in Sandy's front yard. The taller one is 5/4 as tall as the shorter one. 5/4 is telling us that, and the problem even tells us it's taller, meaning it's the entire height of the shorter one plus a little bit more. So it's asking us to write the second sentence with a percentage. That means we need to rewrite 5/4 as a percentage. So I'm going to first find the 100th equivalent and then write it as a percentage. Because we know that relationship as multiplying by 25, which means our numerator is 125. So the percentage is 125%. So if we're rewriting the second sentence, it would be the taller one is 125% as tall as the shorter one. And now we need to calculate the height given the shorter one. So we can use any of the different representations. We can set up a proportion if we wanted to, but I'm going to use the decimal equivalent. So the decimal is 1.25. I find multiplying by that easier, especially with a calculator. So we know it's 1.25 times 160. And I need to get my calculator. So in your calculator, 1.25 times 160 gives us 200 centimeters for the taller triangle, for the taller tree, not triangle. And we knew that would happen because it was 1 whole 160 tall, and then 60 divided by a quarter is 40, yeah. So this next page is when it's not partitioned into factors of 100. So for example, this one is 1/7. 7 is not a factor of 100. So that's why we get decimals within our percentage. Sometimes a question will ask you to round to the nearest percentage. Other times it will say round to 2 decimal points. So this would be 14.28%. And that would be the directions of round to 2 decimal points. So you can see there might be some long division that needs to happen. So what they did was they were trying to find the value of each of these sectors like we did on the previous page. So each sector here is worth 14.28%, but the problem told them to round to the nearest whole percent, which is why they're saying these are each 14%. So let's take a look at these. So the first thing we need to do is decide how many pieces the whole is broken into. So in this case, it's 1, 2, 3, 4, 5, 6, 7. So we're still in sevenths, just like the example problem. But this time, 3 of the sectors are shaded. The directions say to round to the nearest percent. So we know that from the previous part, each of these was 14%. So 14 plus 14 plus 14 tells us that this is 42%. Another way to do this is 3/7 equals some percentage over 100, some value. And we can use your knowledge of proportions here. We can multiply through by the least common denominator. We can multiply through by 100, or if you so choose, you can cross multiply. That's visually what you're doing. So since a lot of you are comfortable with that, I will do it that way. So 7 times x is 7x, and 3 times 100 is 300. And then when you divide by 7, I should say this is a percentage. So 300 divided by 7 is 42.857 blah 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 percent. So if you did it this way and you rounded to the nearest whole number percent, it would be 43%. So just be careful. You want to always give the most precise answer possible. But so if you built on the previous example, you would get slightly less than the expected. And if you did it using a proportion method, you would get something a little bit more than what the actual value is. Looking at this next one, the whole is partitioned into 1, 2, 3, 4, 5, 6, 7, 8 pieces. And one of them is shaded. So I'm going to do it using a proportion again. So 1/8 is equivalent to some percent over 100%. So since you guys like to cross multiply, what I'm really doing here is multiplying through by 8. So 8x equals 100%. So when you divide by 8, you get 12.5%. But the problem told us to round to the nearest percentage. So we look to the right, and that tells us that this is approximately equal to 13%. It would be more precise to just leave it as this, but that's not what the problem asked us to do. Okay. I'm going to skip number 12 and 13 because I think we need to talk about interest. So interest is money usually either charged to you for using money from a loan or money given to you for having money in a, say, savings account, because the bank is thanking you for allowing them to, quote, use your money. So there's two types that we talk about. We talk about simple interest and compounded interest. Simple interest is just that. The interest is applied at one time, and you go from there. It's based on the amount of money either taken out as the loan or the amount of money deposited. What compounded means is that it's interest that's accrued over time, and it's applied more frequently than a one-time thing. So the first thing we're going to talk about is simple interest. With both, you have the idea of principal, rate, and time. So these are all important variables to keep in mind. So we can use I, capital letter I, to represent simple interest, and that's the amount of money paid or earned for use of the money. P is the principal. That's the original amount. So I'll put that here. That's the original. So that's either the amount that you take out in the loan or the amount you originally invest in an account. Rate is the percent rate that the interest is applied. And really important here is it's always written as a decimal. That's why we did all of the work we did of the equivalent forms between the percentage representation and the decimal representation. It's because you're going to need to rewrite a percentage in a decimal form. Time is the amount of time the loan is taken out for, or the amount of time the money is in the savings account. And it's always given in years. So if you're ever given something as, say, 6 months, that means it's half a year. If you're told it's 18 months, that means it's a year and a half, 1.5 years. Okay. So there's two formulas that we can use. The first one is to calculate the amount of interest accrued. So this is the first formula. I equals the principal amount times the rate times the time. And that's literally just the amount of interest gained. Either the amount of interest that the bank is giving you or the amount of interest that you owe the lender. The other formula is A equals P, parentheses, 1 plus RT. So what this means is if we distribute this, it's the principal amount plus the principal times rate times time, right? If we distribute the P into the parentheses. Well, this amount is the interest. So what this second formula is telling you is the total. It's the amount you originally, say, borrowed plus the interest you would owe the bank. So it's the total amount, and it says that right here. Or it's the principal, it's the amount you deposited into the account and the amount of interest the bank is paying you. So if you're looking for the total amount, you may want to use this formula. But this is showing you you don't have to use that. You can calculate the simple interest amount first and then just add it to your principal. Or you can use this formula. Either way works. So let's do a couple of examples. In the first problem, Joe deposits $200 in an account at his bank. The interest rate is 6%. How much interest will he earn over 3 years? So the first thing I like to do when I encounter these problems is to write out the information with the variable representing them. So in this case, the amount he deposits is $200. So that tells me my principal is $200. The next bit of information we're told is that the rate is 6%. Now, be very careful. It's telling you it needs to be written in its decimal equivalent form, right up at the top. So that means this needs to be equivalent, this needs to be written as 0.06. That's what needs to be used in the formula. And then time, 3 years. So we're giving it in years, so we're good. So now we're looking at what the question is asking us for. In this case, the question is just asking us how much interest he gained. So we can use that first formula. So the amount of interest equals the principal amount times the rate times the time. I do like to write out the formula. I suggest you do that. In case you substituted into the wrong formula, I knew where you were going or where you thought you were going. So the interest equals the $200 times the rate written as a decimal times the time in years. Please show me these values. Show me what you're substituting in. Yes, you can use a calculator to do this multiplication, but I need to see these values because if you used a 6 here instead and you just gave me the interest amount, I won't know that was your error. So show me what you're popping into your calculator. So a rule of thumb that one of my teachers always told me was any button you push on the calculator, I should be able to see it on your paper. So in our calculator, we type in 200 times 0.06, make sure it's 0.6, right? Because 0.6 means 60% and we're only in 6%. If you ever find a bank giving you 60% interest on a deposit, you put all your money in there. Times 3 years. So that means he will have gained $12. Okay, the next problem. Ben borrows $900 to fix his car. The bank charges 7% interest for 2 years. Find the total amount Joe will owe the bank. So again, I like to list out my information. So the amount he borrowed was $900. Should put $signs up here, sorry. The rate is 7%, but again, write that as a decimal equivalent, so 0.07. And he has the loan for 2 years. In this case, we're looking for the total amount. So I'm actually going to show you done both ways, using the one that gives you the total amount right away, and the one, if you calculate the interest, how you would then find the total amount. Let's do the total amount first. So that formula was A equals P times 1 plus RT. So the amount would be $900 times 1 plus 0.07 times 2. And now this is where it's really important for you to know your order of operations and to be a parenthesis over user if you just pop this right into your calculator. So I would advise that you write out all your steps and do them in pieces and not just put this right into your calculator, because your calculators are not as smart as you and they will just sometimes read it left to right. So the first thing we need to do is the multiplication within the parentheses. So 900 times 1 plus, so 0.07 times 2 would be 0.14. The next thing you need to do is the addition. So 900 times 1.14. And now we can do the multiplication. So 900 times 1.14 tells us that Ben will owe $1,026. So that answers the question. But if you're not comfortable using this formula, that's okay. We could use the one we used in the previous problem and find the amount of interest. So this is another method, so I'm going to put a line there. So the amount of interest is the $900 times the 7% times the 2 years. So you can, since this is all the same operation, you could just put that in your calculator. So 900 times 0.07 times 2 gives us $126. So what that means is Ben has to pay the bank $126 in addition to the amount that he originally borrowed for the pleasure of using their money. So to find the total amount, we would need to add the original principal amount to that amount of interest that he owes the bank. So the original amount was $900 plus the amount in interest we just calculated. And that gives us the same total we just found, the $1,026. Let's take a look at this next one. Jill needs to borrow $500 for only 9 months. So we see months there, and that should, raise a red flag or bells go off in your mind, right? Because time has to be in years. The bank charges 5.5% interest. How much will Jill owe the bank? So let's still list all this out. So the principal was $500. The rate was 5.5%. Well, I can rewrite that as 5.5%. But be very careful here. Even though that looks like a decimal, we're still talking in percents. So we still need to rewrite this percentage into its decimal equivalent. So that would be 0.055. So be very, very careful with that. Even though this is a decimal, we're still talking in the units of a percentage. So we still need to rewrite it into a decimal equivalent. And then the time is 9 months. But we know time needs to be given in years. Well, we can write this as a proportion, right? There's 9 months out of a total of 12 months. So that would be 3/4 of a year, or 0.75. Using decimals is very helpful because it's easier to use your calculator, to be honest. So the question is, how much will Jill owe the bank? That means the total amount, because she needs to pay back the amount she borrowed plus the interest for the pleasure of using their money. So I'm going to use the A formula. So A equals P times 1 plus RT. So substituting in our values, we have the principal amount of $500 times 1 plus the rate of 0.055 times the years of 0.75. And again, be a parenthesis over user, or just do the steps separately before you pop it all into your calculator. So the first thing we need to do is the rate times the time, because multiplication comes first in the order of operations, within the parentheses anyway. So 0.055 times 0.75 gives us 0.04125. We then do the addition, 1.04125. And now we can do the multiplication by 500. So that means Jill owes the bank, well, I'm going to write out what it says on the calculator. It says 520.625. We know in our monetary system, we don't have a coin that represents smaller than a penny, smaller than 2 decimal points, places after the decimal point. In gas prices and the stock market and stuff, we do go smaller, but not in our monetary bills and coins, right? So a bank isn't just gonna forgive that half a penny. They're gonna round it up, right? If it was a 4, they might forgive it, but it's a 5, we have to follow the rounding rules. So we need to round up here. So Jill will owe the bank $520.63. So make sure your answer is in the appropriate place values for our monetary system. This is an explanation of how compounded interest builds off of simple interest, but we're not going to really talk about that. I'd rather explain the formula more in depth for you. So this is the formula for compounded interest. And what I said was compounded interest is when the interest is accrued and applied more frequently than once over the span of the loan or span of the deposit. So I put a table down at the bottom of frequently used increments for compounding. So it could accrue annually. So once a year interest gets applied. It could accrue semi-annually, which means twice a year. Quarterly, so just like in school when you had quarters, it was 4 times a year. Monthly is 12 months. I don't know if you remember that. There are 12 months in a year. Weekly means 52 weeks. So you can think about it like a deck of cards. There are 52 cards in a deck of cards. There are 52 weeks in a calendar year. Or interest might be applied daily. Means there are 365 days. There is something called compounded continuously, which we're not going to really talk about in here because that is very much a high school topic because it involves what's called the natural log. So we're not going to do that. But these are the main increments. So increments or intervals, that is a new variable to this equation. You can also see the equation looks a little different. We still have the A, the P, the 1, and the plus. But now the original rate is spaced out over the intervals. So if the interest is applied annually, that rate is just the rate, just like it was for simple interest. But if it's semi-annually, that interest rate is applied over 2 periods. That's why we divide it twice. If it's applied quarterly, that means that original rate is spaced out over 4 intervals. So that's why we're dividing by n here. And the work that I did up above that explains this through an example, the relationship ends up being exponential. So over the course of the year, or years, the t, we have to raise it to the exponent and multiply by the number of intervals. So again, over the course of a year, if it's applied quarterly, well, you're really applying it 4 times a year, right? So over 4 years, that's 16 times. Over 20 years, that's 80 times. So that's why we have to do this multiplication up here. So this is an exponential form. My advice for this, when you go to substitute into a calculator, is be a parenthesis over user, and again, do it in steps like we did with the previous problems. Find the new exponent doing the multiplication. Find this r divided by n. Do the addition, and then do the exponent, and then the addition. So we'll do some in pieces. So these are the important variables for the problem, defined just like they were on the previous one. Rate is still given in a decimal. Time is still given in a year, but the new one is interval. So interval refers to something like that. Okay. So let's do a couple of examples and see how we do. I just have to get my other calculator ready. Okay, I think I'm ready. So we have a 3-year investment of $20,000 that received 5.2% interest compounded semi-annually. What is your total return? So just like before, I like to list out my information. So the principal amount, our starting amount, was $20,000. Our rate is 5.2%, but just like that last simple interest problem, we have to be careful. Our units are percent, so we need to write the decimal equivalent of this, which would be 0.052. This is phrased a little differently. We're told the years up front, so it's a 3-year investment. And now we have to remember the interval or the increments that the interest is accrued. So semi-annually means twice a year. So we can even label it up above if this is helpful for you. Label the problem. So semi-annually tells us our interval is 2. Okay, so now we can write out our formula and substitute in our values. And again, I highly suggest you do that. So A equals P times 1 plus R divided by N to the NT. Now let's substitute in our values. I'm going to do it to the right because I don't think I gave myself enough room. So we have the principal amount, $20,000. Make sure you have the right number of zeros. So there's 4 zeros, so there's 4 zeros. 1 plus 0.052 divided by n to the, so this is an exponent, be careful, it's not multiplication. I mean, there's multiplication in the exponent, but this is another term for multiplication. 2 times 3. So the first thing I suggest is to do the multiplication for the exponent and the division for the rate and interval. So nothing else has changed. So 0.052 divided by 2 is 0.026, and 2 times 3 is 6. Now do the addition in your parentheses first. So we're not touching that 20,000. That is the last step. A common error I see is people do the addition and then this multiplication and then try to apply this exponent. and then you get a ridiculously large number. So the multiplication by the principal is the last step. So this becomes 1.026 to the 6th. And now we need to do this exponential form first. So in your calculator, you should have a little sign that looks like a caret. So what you're going to type in is 1.026 caret 6. Okay. If you can't find the caret, you could do 1.026 times 1.026 6 times, and you'll get the same thing. So we have 1.026 to the 6th, and that gives us 20,000 times 1.1664984 blah 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 blah. And my advice to you right now is don't clear that calculator. Don't type it in. Once you get that value, then hit the multiply button and 20,000. So that way you're not rounding and truncating that value, and you'll get the most precise answer possible. So after this blah, 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 blah shows up on your calculator screen, hit the multiplication sign and hit 20,000. So that equals $23,329.97. That is rounded. It was 9689. But just like we talked about, we needed to round to a penny, to the pennies. So that is the most precise answer. Let's try another one. So we have a 6.25 year investment of $40,000 at 14% interest compounded quarterly. How much is it worth now? So let's list out our information again. So our original amount was $40,000. The rate is 14%. So we write that as a decimal. So 0.14. Time was 6.25. So again, the easiest to use in these formulas is a decimal equivalent. So 6.25. And the intervals is quarterly. So quarterly means 4. So let's write out our formula and substitute in. So A equals P times 1 plus R over N to the NT. Substitute in your values. So 40,000 times 1 plus, I'm going to scribble that out so it doesn't get confused, 0.14 divided by 4 to the 4 times 6.25. So that's just substituting in all your values. And then just like I did in the previous problem, I'm going to first do this division and this multiplication. So 40,000 times 1 plus 0.14 divided by 4 is 0.035, and then 4 times 6.25 is 25. The next step is to do the addition within the parentheses. So 40,000 times 1.035 to the 25th power. And again, the most common mistake I see is to incorrectly do this multiplication first and then try to raise that really big number to a power, which your calculator gets really confused and starts spitting out scientific notation. So remember, multiplying by the principal is the last step. We have to do this exponential form first. So 1.035 to the 25th power is 40,000 times 2.363249 blah 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 blah. And then just like before, we're not going to clear our calculator. We're just going to leave that on our screen, hit multiply by 40,000, which gives us $94,529. And in this case, the decimal was 0.799. So when we round, we get 80 cents. Let's do two more. So your $440 gets 5.8% compounded daily over 8 years. What will be your $440? What will your $440 be worth in 8 years? So let's list out our information. So the principal was the original $440. Our rate was 5.8%. So again, it's a percentage. We need to rewrite this in a decimal, even though it's already started as decimal, we're in percent units. So 0.058. Our time is 8 years. And then daily tells us our intervals are 365 days. So let's write out our formula. A equals P times 1 plus Rn to the NT. Substitute in our values. So 440 times 1 plus 0.058 divided by 365 to the 365 times 8. Just like before, I'm going to do this division and this multiplication first separately. So the 440 hasn't been touched and the 1 hasn't been touched. So 0.058 divided by 365 gives us a really, really small number. Ooh, it's 0.00015. I did round that. And then 365 times 8 gives us 2,920. So I did round that because it does keep going. At that point, it's okay. 1.000159 to the 2,920. So we did the addition. And now, just like I said before, we're going to do this exponential part first. Ignore the 440 until last. So 1.000159 to the 2,920 gives us, oops, I lost it, 440 times 1.59089 blah 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 blah, and then I'm just going to hit multiply 440, and I get $699.96 because we rounded. It was 0.956, so we rounded. Okay. One more. Your $54,200 2-year car loan, that's a very quick car loan, is at a 15.1% compounded annually. What will you have paid for your car after 2 years? So again, you're paying what you actually, the car was valued at, and plus, because you borrowed money from the loan, for the loan you have to pay the bank for the pleasure of using their money. So let's label it. So the principal was $200. The rate was 15.1%, so rewrite it as a decimal. So 0.151. Time was 2 years. And compounded annually means our n is 1. So this ends up being still the same formula, p times 1 plus r over n to the nt. Substitute in our values, $54,200 times 1 plus 0.151 over 1 to the 1 times 2. By showing what you're substituting in, by showing how you evaluate the exponent in that division, if you make one slight error, I can see where you went wrong, right? If you just do this and then jump right to the answer and the answer is incorrect, I don't know where you went wrong in the middle. Okay. So $54,200 times 1 plus 0.151, because divided by 1, and times 1 just gives us an exponent of 2. So $54,200 times 1.151 squared. We do the squared first, so 1.151 squared. No, I think I did that wrong in my calculator. All right, pause. 1.151 squared gives us 1.324801, and that truncates, it stops. So then do this multiplication. So you would have ended up paying $71,804.21 for the car that was originally $54,000, right? So we could actually figure out how much interest you ended up paying, right? This is a tangential problem. So if we wanted to find the interest that you paid the bank, it would be the amount minus the principal. So the $71,804.21 minus the original amount, 54,200. So you paid the bank an additional $17,604.21.